So for question 4, we've been given a coordinate geometry equation question. We're given 2 points here for part A, and we're asked to find the equation of the line that goes through these 2 points. So I'm just going to copy down these 2 points. So A is minus 1, 3, and B is 4, 4. All we need to do is find the line that goes through these 2 points. First thing to do is find the gradient. There is a version of the formula that you can use without finding the gradient, but I prefer to find the gradient first. So m is y2 take y1, x2 take x1. We're going to make this point 2 and this point 1. So this is 4 minus 3, because these are the y coordinates, over, and then we've got the x coordinate, which is 4 minus minus 1. Which gives us a gradient of 1 over 5. So that's our gradient. We're now going to use y minus y1 equals m, x minus x1. This is the preferred straight line equation formula for the exam. There are several different versions of it, but you can use whichever one you're happy with. So we're going to use this as our 1 point. So this is y minus 3, because that's the y coordinate, equals 1/5 x minus, and then we've got to be really careful with this minus and this minus, minus 1. If we refer back to our sheet, we're asked to give this in the form ax plus by plus c equals 0, where a, b and c are integers. This means we need to get rid of this fifth. So I'm going to multiply through, so I get 5y minus 15 equals x plus 1. And we're going to group everything up over onto, I'm going to bring everything onto this side. So we get 0 equals x minus 5y, and then we're going to have to add a 15 here, so we're going to get plus 16. And that's our equation of a straight line. You could, if you wanted, have it the other way around, so you could have 5y minus x minus 16, that's acceptable as well. For part B, we need to have a look at our diagram. So for part B, we're given C and D lie on the straight line L2, remembering that this is a parallelogram, which means this line here has to be parallel to this line here. And we get given the equation for L2. Show the distance between L1 and L2 is square root k, where k is an integer. So we're after the distance between these two lines. This is also worth 8 marks, which means it's not just going to be one simple method. It might be quite helpful here just to go over here and just mark on our diagram what the distance is. The distance is this dotty line here. So it goes between there and there. Another useful fact to remember is if we're trying to find the distance, this is the same thing as what we call the perpendicular distance, so it's this perpendicular thing right there. So now we start thinking to ourselves, what bits of coordinate geometry have we done that involve anything to do with what we've done now? Well, I know the gradient for here is m is a fifth, which means the gradient for this one here is going to be m equals, we need minus 1 over, so we get minus 5. So we can work out, let's call this L3. We could work out an equation for this line here, and then we can work out this point here. I'm going to call this E, because it's on this line L3 and this line L2. And lastly, we can find the distance from A to E. So 3 different things in here, but that's why this question is worth 8 marks. Some of the coordinate geometry ones are really tricky to work out what to do, but that's what we're going to do. Start off with, we're going to find L3. L3, which is the line connecting A to E, has m equals minus 5, and we know it goes through the point A, minus 1, 3. So this is y minus y1, which is 3, equals minus 5, x minus minus 1. So this is y equals minus 5x. Here we've got plus 1 times our minus 5 gives us minus 5, and we're adding 3 gives us minus 2. So we have a quick look back to here. This looks like the right kind of thing. It's going to cross through here at -2. So we've got our line, our perpendicular line, and we want to know where this crosses, and they gave us this equation in the question, which is quite nice, which makes us think we're on the right track. 5y minus x plus 10. Equals 0. So we need to take these two things and solve them together. So I'm actually going to take y and sub it into here. So I get 5y, which I'm going to replace with minus 5x minus 2 minus x plus 10 equals 0. All I have to do now is solve this. So I get 25x minus 25x minus 10 minus 25x minus 10 minus x plus 10 equals 0. So we get minus 26x. We get minus 10 and plus 10, we get equals 0. So we get x equals 0. We also need to know a y coordinate, so I'm going to find that by putting it in here. So if I put this in here, I'm going to get a 0 for this. So I'm going to get 5y plus 10 equals 0. So I get y equals minus 2. So this means our point E is actually 0 minus 2. And you can see, you might be able to hear the jet fighter in the background. Once we've got this, and we've got our point A, minus 1, 3, all we need to do is find the distance. Because we looked on here, E is the point that's perpendicular to A. So we need the distance from A to E. That will give us our distance. So our distance formula is D is the square root of, and now all we're going to do is find the difference in the x. So this is 0 minus minus 1 squared plus the difference in the y. So this is minus 2 minus 3 squared. This gives us the square root of, here we get 1 plus, here we get 25, giving us square root 26. For the last part of this question, let me just find some more paper. We are asked to find the area of parallelogram ABCD. So here we've got a height and we've got a length of a base. If you remember back to secondary when we looked at parallelograms, we could find the area of a parallelogram just by doing the height, perpendicular height, times by the base. All we need to do is find the distance from A to B to finish this question off. So we know that A and B are written here. So A minus 1, 3 and B 4, 4. We need to find this distance and multiply it with the perpendicular height that we've just found. So this is square root of t equals this one and this one, 4 minus minus 1 squared plus this one and this one, 4 minus 3 squared, which gives us square root of 25 plus 1, which gives us square root 26. So area of parallelogram is base times height, which is square root 26 times square root 26, which is 26.